Okay, now we're going to identify line of intersection of two planes. So when two planes intersect, they form a line. Okay, there are two scenarios here. The two planes must either be parallel or they must intersect in a line. Okay, to determine the equation of a line where the two planes intersect, you need to know two things. It is similar to finding equation of a line in a 3D space, yeah. So which is you need to know the direction vector and you need to know a point on the line. So in order to find a point on the line, you basically need to make some initial assumptions based on the two plane equations given. So the line must either cross xy plane or be parallel to the xy plane. So first scenario, if the line crosses the xy plane, the assumption is z is 0. Okay, and when you set your z as 0, you can actually reduce your two plane equations in terms of x and y only, right? So then next you can actually solve these two simultaneous plane equations which only has x and y, and you can find the point which is represents, for example, x1 y1, and your z is already set as a 0. Second scenario, if the line is parallel to the xy plane, then you should set that your y is actually 0. You can make that assumption. So you need to read your question carefully and to identify whether the line crosses the xy plane or the line is parallel to the xy plane before you make your initial assumptions. Next, you need to identify the direction vector. So the first thing you have discovered how to identify the point, and next thing is how to find the direction vector. So based on this diagram here, when two planes intersect, this is basically say the line of intersection. Okay, two planes are intersecting, so this is plane 1, right? And the horizontal plane, the vertical one is plane 1 and the horizontal plane here is n2. Okay, it forms a line, right? So two planes intersect and this will be the line of intersection, right? And then its direction vector is perpendicular to the normal vector in each plane. So as you can see, the normals are this 90 degrees to the plane, right? To plane 1, 90 degrees. And the direction vector v1 is perpendicular to the normal vector. Okay, same goes with n2. N2 is the normal to the plane, all right? So its direction vector v is perpendicular to the normal vector n2 as well, right? So in conclusion, the direction vector will be parallel to the product of the two normal vectors of the planes n1 and n2. So this is the theory. So when you are required to do calculation, you can straight away work out that when two planes intersect, the cross product or the vector product of the normals of the two planes, the normal vectors of the two planes, represents the direction vector of the line. For example, if you're required to find equations of the line where two planes intersect, right? So these are the two plane equations, all right? So to start off, you need a point on the line that is the resultant of the two plane intersection, and you also need the direction vector, right? So based on our previous slide, yeah, so you make an assumption that z is 0, okay, because you are assuming that the line is on the xy plane, okay, crosses the xy plane, so you assume z is a 0. By assuming 0, c0, you substitute z as 0 into both the plane equations. So you will reduce your equations to x minus 2y equals to 1, right? And 2x plus y equals to -3. So you eliminated the z, right? So now you have equations x and just in two terms, two unknowns, so you can actually solve them. What I did was I I got x in terms of y. So in this case, I've got x here as I've got x as 1 plus 2y. Okay, 1 plus 2y. Okay, I manipulated the first equation. So I substituted x as 1 plus 2y into the second plane equation. So it becomes 2 times x. So it becomes 2 times 1 plus 2y. Okay, plus y equals to negative 3. So I solve my y. Okay, and then you can solve your x. So you will get the point of intersection. So do not forget the z as 0. Okay, do not just write your point as x and y. It has to be x, y, and the initial assumption z is 0. Right, so this is your point of intersection. So next, you need to identify the direction vector. So in order to identify the direction vector, as we can see, the theory states that the cross product of the normal vectors are actually the direction vector of the line. So we need to identify the cross product for both vectors. So the first normal vector to the plane will be 1i minus 2j plus 3k, right? And then the second normal vector would be 2i plus j plus k. So we are assuming it's u and v, right? Then we find the cross product. So in order to determine the cross product, you can use the shortcut method that I have showed you in the earlier lecture slides. Okay, use the shortcut method, and it's a cross product. So, or vector product is definitely the resultant is a vector. So in this case, you will get negative 5i, negative 5 plus minus 5j plus 5k. Next, you have got the direction vector. You have got the points. So you can come up with the line equation now. So in order to identify the line equation, it will be the direction vector will be in the denominator of the line. So we normally write it in symmetric form, yeah. So the denominator of the line, negative 5, and 5 for x, y, and z respectively. And then the point is negative 1, and 0. So it will simply be x minus the point. So x minus negative 1 is x plus 1. Y minus negative 1 will be y plus 1. And z minus 0 is z. So you can identify the equation of a line in symmetric form. Bear in mind, you can also simplify the denominator here. You can always divide the whole denominator with 5. And you can reduce your equation to x plus 1 over negative 1, y plus 1 over negative 1, and z over